Good afternoon. In next 45 minutes, we're going to go through the journey of processes, obviously go from waterfall to agile to DevOps. Microservices cannot be in itself without talking about the processes. But let's start with the first thing, monolith. I mean, a big rock is a monolith. A big mud is a monolith. What do we consider monolith? I mean, if you want to take attributes of monolith, I would say take a stack when we moved from client server to n-tier based architecture. Let's take a Java J2E stack, or let's take a .NET C# based stack, and let's see how that evolves. You have a n-tier based application which talks to a data store. You have shared libraries which different services leverages. You have those shared libraries making call to database or other storage. You are starting to build the coupling. You're starting to build getting tightly coupled. When you build it, you get a big DLL or ZAR output. And anytime you have to do change, you start seeing those blockers. You have big teams. To associate it, that's how the monolith evolves. And it reaches to a point where you can't move faster. You actually hit a roadblock. And it's long term. You have merge Fridays. You have days in which you are actually figuring out, oh, this is prod branch. This is my pre-prod branch. This is my bug fix branch. How do I merge those code changes? That's the monolith. Now, what's the pitch here to understand? I want to give you the scenario run through. You probably have heard this. Amazon.com in 2001 was kind of monolith and was hitting similar set of challenges. Any changes was taking months to actually get through. The home page itself was so big that you needed a release team to coordinate different components of home page to be released. That's where Amazon.com was. So the stack we are talking is Obidos, and it moved towards the GroupI stack, which is a web server, and it has a thrift-based calls which can make to either database or a file server. Now, how does that move in? Let's take the challenges that we see. We are difficult to scale, obviously. Once you have a monolith, you actually replicate the whole thing, right? I mean, if you take the age-old load balancer, what do? You replicate the whole stack, not necessarily the place where the request is coming in. Different services could have a different request throughput expectations, but you actually replicate the whole stack because that's how it gets scaled. Long build tests, release cycles, that has to do with little bit in the, if you take the waterfall to agile, that even agile, many people used to do mini waterfalls inside that. So that has to tie with the processes. And the whole group which is developing it, it's large teams. It's not small teams sectored. So the large teams have to have so much of collaboration. That's another reason. Operations is nightmare because if you see the age-old segregation, you have a dev team, you have a test team, you have an operations team. So there is a good amount of separations. Dev team releases the code, it works on my box, I am done with it, I don't care if it doesn't work on the other side. So there is no ownership. That's the primary reason why operations is a nightmare, because when you find a bug, it's like, who wrote this, who is the owner for this? Some time goes in just figuring that out. What is the end result? Obviously, I as in a customer, I would be definitely frustrated. If I give a feature request, I would want that feature request to not to hear that, oh, this has been taken into roadmap, it'll come in 2019 first quarter. Okay, that's definitely not something I want to hear. Lack of innovation. Obviously, there are so many ideas. And those ideas, if you want to implement, you have to have a very, very fast cycle between the idea and getting in the hands of the customer. What actually happens with waterfall and monolith is that you spend so much time between this that by the time you came here, maybe there is a better idea to actually work on. Common challenges. Now, as we have heard, I have been given a box that I can't come out of this, so I'll try to be inside the box. The whole dev team is working. Let's take an example of a 1.0 application which has 80 developers, right, just to make it real. Now, there is a good amount of coordination. There is a release team which works to get each component, and then, okay, this has a dependency on this, this has a dependency on this. I need to get this built first, then this built first, that's how I'll get it. You will have 2-3 iterations where you'll find, oh, I deployed this, but no, the signature is different. So you have that churn. You get into, now if you see this is typical like a bandwidth thing. You have so many teams releasing it, but they have to go through the same build cycle. End-to-end release process, they have to go through the same. So that is another biggest blocker. Because there is good amount of days when you plan for those release. It is not like if a service on its own can build and can release, agnostic of others. So if you have that collaboration needs, you are actually blocking how teams can work and proceed. Too much software coupling. When you say coupling, we evolved from client-server to services model. You started doing sharing of code. So if you take age-old structured programming, you have a function as shareable code. You move into object-oriented, you have classes, which is shareable code. You moved into components. You moved into shared libraries, could be a DLL, which either runs inside the same address space or is hosted across different processes. But it is a shared library. It has a version. Multiple teams will use the shared library. Now what happens? There is a version associated. Each team can be at different versions. Again, you will hit the issues there. I need the latest version. No, he can't change. So everyone has to change to support that latest version of the component. That's the reason where you have too much software coupling. Shared data. This is another issue. If all those different entire components are talking to the same database, and if you have a schema change, you dropped a field, you added a new field, you had a query which outputs something, it will end up breaking. It is very hard to reverse engineer what are all the places those calls are being made for that database. Usually it ends up being break, build, deploy. Either you find it because certain things you can find at the build time, but some things you find at the runtime when actually the call happens, right? So you have shared data across different services, and that becomes the blocker. So 1, shared libraries, 2, shared data. Those two primary things that the microservices world hits. Before I go into microservices, how the Amazon divided, let's discuss what actually, in terms of definition, what is a microservices. There's a Wikipedia definition. And this is one of the definition given by Adrian Cockcroft. He's our VP of Cloud Architecture. I'm sure service-oriented architecture, many people will say, yeah, I kind of feel like it's similar. It is service-oriented architecture. If I have to say, when we moved from client-server to N-tier or services model, we got into service-oriented. But it is today that we are realizing how a unit can be a service. So a unit as a service has to have its own data store, what it is manipulating. It has to have its own devs release pipe cycle. Then it is on its own. It's a unit on its own. It is no dependency. Services communicate with each other over a network, over a standard protocols, HTTP, HTTPS, AT443. You are talking with each other. We can talk about performance impacts of different services and going over these layers, but they are talking on a standard protocol. That's one of the key. They are not going the other way. Loosely coupled elements. Essentially, each service can change itself, agnostic of other. I mean, yes, there is a signature that you have to adhere. You have to have a plan in terms of if you have a signature change, have a way in which you have a version change and intimating the clients, and then you move towards new signature. But you're loosely coupled. Everyone can run on its own. Think of it like a team. Each person has a different speed to work. If you make them together that you have to go into meeting together, the slowest guy will make, that's the speed, the lowest speed. If they go on their own, the fastest guy can do things faster, and that way you gain advantage of that. Bounded context. This concept comes from like a domain modeling, where you're thinking of your microservices in one particular domain or an entity. If I take, let's take college. You have student as an entity. You have a teacher as an entity, course as an entity. You can directly correlate microservices with the same. I can have all student-based manipulation, student-based store, exposed as an API, REST, Again, REST has its own history. We kind of went from 1960 where we got the HTTP verbs to packaging, wrapping, SOAP layer, and then, oh no, this is too much overhead. Let's go back to HTTP, right? So that's where the REST is, and that's becoming the standard. So you have a REST-based API. You have a service which has its own data store. That in itself is microservices anatomy. So you have the application logic, you have the data store, and you're exposing them via public HTTP REST endpoints. Okay? You are avoiding coupling by going through the standard protocols. You are not having either a reference, callable wrappers, interfaces inside the abstract factory-based loading. There is none of that. It is call. The call goes to network layer, HTTP, TCP, get the call back. You don't have any dependency. Now that service can be used by any other members of the team because it's on a standard port. If you have a shared library, it has to be shared, gone, somebody has to track whenever you change. There's good amount of dependencies that it brings. If you go through the standard HTTP-based hosting services, you avoid that coupling. There is a performance impact of it. That's something you have to always have it in mind. Yes, there is a question?
So how do they call to one another? Is it through an API?
Yes, so it's the HTTP. If I have a student API and I have a course API, so to manipulate student API, you call the student one. Now, if you are talking about orchestration layer, like if you have a call which can span across multiple services, API gateway is the answer from the AWS. So you need a gateway kind of architecture, which is the front, and all the microservices are abstracted at the back.
So the API gateway is an Amazon service?
Yes.
And you link up all the microservices to it?
Yes.
And you communicate and coordinate communication between them?
Yes, we will actually talk about that. Yeah, no worries. Okay, this is another example of how a restaurant microservices would evolve. You can see payment takes care of payment-based processing. Location has location. And now if you see, you can easily correlate, like this could easily be reusable across different needs. Wherever there's a location-based need, like GPS coordinates or where you currently are, drivers, restaurant. So the more generic and unit is accomplished on its own, it is more reusable. Okay, so there is one element of how these software teams have evolved, right? As I said in the initial start, there is a developer, there is a tester, there is a QA, there is analyst, there is BD, business development, there is solutions manager, different roles in a whole SDLC, right? Agile tried to break that, like, hey, you have sprint teams, the Scrum version of Agile, and it is a combination of dev, test, PM, and they're working together. They are doing design together, they are doing test together, they are doing test-driven development together, and even the skill set is supposed to be everybody doing the same. Dev can do sometimes test can do actually sometimes dev, but in reality, what ended up happening was you had mini waterfalls inside those sprints. So if it is a 1 month sprint cycles, 1 week of design, 1 week of development, 1 week of deployment, and last week of maybe stabilization, and there are some bugs identified which goes to another sprint. So one of the another reason in the industry is there is like, you can ask people, you're a developer, okay, are you a UI developer? Are you a middle tier developer? Or are you a database developer? So UI developer kind of HTML, JavaScript, CSS, or if you take thick client, there is some kind of UI based SDK that they know. Middle tier, mostly it's a services stack. Either they do the SOAP based services or HTTP based services. They're writing middle tier services to process the request coming in. And the database guys are more in the either database functions, triggers, designing database, or DBA tuning. Now sometimes that drove how the actual application architecture was. So we will divide this application into a UI application, a middle tier application, and a database application. That itself tells you that that is not the way you are going to divide once you go into microservices. You're going to design in a cross-functional team, and it's a self-contained unit. You can combine a UI guy, a middle tier guy, or DBA guy together. Yes? Sorry?
This column, the Conway's law.
Yeah, so this actually goes into the siloed application model, right? where you have each UI application is separate, the middle tier application is separate, because the skill set is driving the architecture. Whereas once you go into the microservices architecture, you have a team which is cross-functional and it is self-contained. The idea is it's not the skill set that should drive the architecture of the application. Sometimes I have even seen this, like large application, it's very hard to work on a Eclipse IDE or a Visual Studio IDE. They create separate solution just to satisfy that. They create separate, because we have separate dev teams, oh, I'll give you a separate project for you, because the project gives outcome with a jar or a DLL. That's how it gets divided. The idea is when you go to microservices, you're not going to think of that. You're thinking from an entity perspective and a business domain perspective. So we come to the Amazon terminology. We have this concept of two pizza teams. I'm pretty sure you must have heard by now. So a service is as many people who can be fed by two pizzas. That's the idea there. So it's smaller teams. Full accountability, that is critical. Right from the requirements to designing, to developing, to deploying, to user experience, to stability, to supporting, it's the same team. It is end-to-end ownership, not I have developed, it's working on my machine, I am done. That actually adds more, and the more layers you add, the more complexity for an application. So that's the idea behind Amazon DevOps model, where you have the team divided smaller chunks who own end-to-end. The architecture is you are actually thinking of your application into small subsets of microservices, and each microservice is kind of an entity, one entity which has its own data store, it has its own API layer on top of it. Okay, so that's the idea here. Each one of them can do their build, release on their own. They do not have to be having a release day or a release week or a merge Fridays. It does not mean that there is no collaboration. There still is collaboration. Obviously, there is signatures. API has signatures. A signature is a function which has different layers of parameters. So whenever there is a signature changes going on, there has to be some communication. The idea is the design of the service should be in a way that it has backward compatibility built in, and the versioning, the semantic versioning that we have, the major, minor, and the patching based, that should give the actual end users of the API an indication that, hey, this API is going to be deprecated. You better move to this particular API and give them time. And the next time when a major version comes, they're ready for it. They're prepared for it. Okay? So yes. Each is a microservice. In this representation, you have 1, 2, 3, 4, 5, 6 microservices being developed.
Well, you've got, 5 services, 10 services, you've got one team of 7 people or 5 people, right? So each one of them has to have its own service.
Yes, so again, the service, like if you talk AWS service, you literally have a managed AD service with 8 people. It's a big service ask. Now, if you're dividing a smaller application, there it could be that one person can own one service and can do it. But usually, a large, like a service expectation is you will at least need more than one people to do the actual work. The composition of a microservices team for a small application could change. I would definitely give you on that. So, yeah, go ahead.
Previous question, I'm not sure. That's a Conway's law, and talking of the principle of software development, we define your problem, and your objective is to have a solution. And this microservice module decoupled. So what happens, those concern of the team's module is not my major thinking. My major thinking, achieve your solution when you define the problem, you test it, get the good solution. So ultimately, is it correct my understanding that Conway's law says that this team's module actually, the modular type, should synchronize themselves with the operating the system, is correct?
Yeah, that's very, very spot on. Now, there is an element of architecture advantages that we have not even spoken about. Like if your things are being designed in microservices, they can scale on their own, right? They can scale on their own. You can abstract things on their own. Like today, a microservice is abstracting a data store something. Tomorrow, it can change. We will talk. There are a lot of in terms of how you are designing the actual microservices, the frameworks. It'll get more clarity once we have covered that. Okay. Okay. This is a sample of how it evolved and the different microservices that the Amazon took the journey. This is a build number across all the teams. With microservices architecture, you move to 50 million deployments a year, 0.63 per build. Now let's go into what are the implementation options, and at the end we will see the architectural advantages. So how do you go about implementing in AWS, right? The first obviously is Elastic Compute Cloud. You use EC2 instances, you have a web server, some kind of either Nginx or IaaS or others, and you host your web services there. You have a load balancer layer to host it. So you have a load balancer. The services are in the EC2 instance. This can scale. It is talking to the database layer. The deployment could work via the Elastic Beanstalk. That's the plain vanilla, the first level which you talk. The second, which is the EC2 container service. This is where things become more interesting. You are actually talking about different services, and the services have tasks. Now, you could actually gain by using container service. It gives you automatic scheduling, the orchestration of it. So you still have EC2 instances, but the orchestration will make sure that it deploys different services on different EC2 instances. And that plumbing is done by the container service. EC2 also container service also has integration with ALB. ALB is the layer 7 load balancer. So layer 4 and layer 7. Layer 7 actually helps you have multiple copies of same service on same host using the host headers. So you can actually use EC2 instances more. The utilization grows more. In the previous case, you will have mostly one because you tie it to a host and port. In this case, you can have n number of it depending on your EC2 instance size and your service expectation of memory, what it needs. So that's another one. It is built, you can have the end-to-end CI/CD with the AWS build pipeline. The next, which is obviously when you say microservices, what is micro? Is it a service which has all the APIs of the micro? Or is a function a microservice, right? And that is a separate debate which I don't want to go into. API backend, like an API gateway backend could be Lambda. And Lambda is basically nothing but a function which triggers. Like in a database, there is a trigger which gets triggered when there is a change or the event. Lambda actually gives you a new architectural pattern in the cloud. Oh, whenever there is a S3 object update, whenever there's a new object being added, trigger Lambda. Kinesis stream, trigger Lambda. So you can have an event-driven for AWS cloud kind of programming with Lambda. It does have a limit of 5-minute execution time. So anything in that function has to be finished within 5 minutes period. Yes?
When do you know Lambda sounds very sexy.
Yes.
So when do you know that you don't necessarily need it and you're better off with microservices, or you should take the learning curve and introduce Lambda to engineering and have them build functionals?
Okay. So one key thing is the amount of time that function is going to take to execute, right? Lambda has 5 minutes execution time period. So it has to finish within that time period. That's one. If you have a long running call, done. Lambda is not the right thing. Microservices, an API gateway backend could be Lambda. So a call that comes to API gateway, it can actually invoke Lambda. So Lambda is also a form of implementing microservice. That's what I meant to say. Now, whether you use Lambda for short running calls or you use ECS jobs for long running calls, right? Or you have your own HTTP endpoint hosted somewhere, it will be, all those are choices which you have. Like once you have the API gateway created, you can either have Lambda, you can either have ECS container invocation, you can either have your own HTTP based service. These are all different ways in which you can implement microservice.
I guess what I'm saying is
Yes. Yeah.
when you select that.
Uh,
Because price performance makes Lambda the second attractive choice.
There is one key difference here that if you have seen the shared responsibility model, with EC2, there are things that you have to do, right? Patching on top of it. Lambda is abstracting you from all those plumbing. You do not even have access to log into the machine where the Lambda is executing. All you have control is give me the function, define the amount of time, or maybe if it needs to have access to some other thing, that's the level. So it's an abstracted higher level. But if you have the need, like, hey, I do need to go manipulate, I have custom things that I need to have. If you have Docker-based instance needs, so there are other things that will be at play when you want EC2-based service, or a EC2 container-based service, or a Lambda. There is an element of how much operational work also you want to take that will come in. And it will also depend on your application dependencies, because sometimes getting all dependencies working in Lambda is a little bit harder than getting it working in a EC2-based services.
Thank you. You explained very well Lambda abstraction. And you're saying this is a serverless service.
Yes.
And it's very nice. That abstract is a key point defining Lambda as a serverless service. But my, could you help me please? When you have events is going to trigger
Lambda function.
to Lambda.
Yes.
And Lambda module abstract is going to trigger the function to get the solution.
Yes.
So where do you get the source of events? Events as a result of some action. For instance, I start in red line, that's one event. Would you explain that where do you store or get your source of events? Is it S3 or bucket or in EC2?
So you're saying where is the metadata that actually,
Source of events comes.
so there are different sources that could be.
Say,
Yeah.
we have to have a kind of integration from front back to the end back.
Right.
In order to have that one, we have source of methods like get, post, all resources,
Right.
resources. Would you explain where do you get that your events?
So I'll give you a high level for the underpinnings of how it works. We may need to have more conversation. So there are different services that support Lambda callback. And there is an underpinning infrastructure that they subscribe to. Whenever that event happens, it's like a IAsync result of a callback. Like when you call something and you say, when it's finished, call me this. So there is an element of the events that you associate. That event, like I want to have a S3 put, I want this Lambda to be invoked. You configure that hey, whenever there is this S3 put event on this bucket, please call this particular Lambda. That configuration goes into a plumbing, and that's being monitored whenever that call comes in. Now, how that actually, the data structures of it, I can explain you after, or we can take that offline. Okay, thank you. Okay, so these are the options. Lambda can be implemented with so many different runtimes, Java, Python, Node, and now it supports .NET also. Serverless endpoints, it automatically scales. There is an element of first time launch issues, right? It can take some time because as you know from the Java or .NET world, the first call is slow because it's doing JIT compilation. The same thing goes here also. There is also another element of spawning things and getting it up to speed. There are ways you can speed that up, or you can pre-warm things. Like for ELBs, you can pre-warm to the scale for some kind of DDoS attack. You can pre-warm things at Lambda also. Okay, so API gateway, that's the key here. This is the glue that gets you. This is the front end for the clients. When I have microservices, let's say I have 10 microservices in my application, there are two ways. I expose each one as a URL to the client. No, that is not the idea behind microservices, because you again got a coupling in terms of endpoint. The service discovery is what you want to use. API gateway gives you several advantages. Create a unified API front end for multiple microservices. It's one unified. It takes care of abstracting the back end microservices. Authenticate and authorize. I don't know, OAuth, SAML, JWT token. What happened to this? Something. Yeah, some event got triggered. Okay, great. Thank you. You're the man. Okay. Another advantage, DDoS protection, distributed denial of service. It is built into the product. The CloudFront POP are the first ones who are going to get that request, and based on the user's region, it will route. You have caching. You have different caching that's available, output caching that's available via API gateway. So there's significant advantage with the API gateway as a front for all other microservices. Storage, obviously, I mean, I have DynamoDB as a NoSQL, but technically there is a term called polyglot frameworks and polyglot storage. I mean, it's a fancy name. Basically, use the right storage mechanism for right needs. I mean, if you have RDBMS need, you will use the RDS or other RDBMS engines. If you have caching, searching, you will use the Elasticache. NoSQL-based needs, you will use the DynamoDB. This is one example of how Guilt, which is luxury designer brands, actually created their own Lambda. I would highly recommend if you can go to like sometime find time to go through this session. It has an end-to-end journey from monolithic to microservices for the Guilt application, if you see. Browser, load balancer, storefront UI, API gateway has the different layers. This is a obviously first layer. You could have the Lambda-based implementation also. This is like a common set of architecture. So I'm going to break the rule. This is the client. You get the request in. The client request comes to the POP first. We have, last I know, 76 pop-up locations for the CloudFront, right? That's where the first request comes in. You can gain advantage of the regional caching of pop-up for some kind of files that are static in nature. For output caching, you can gain advantage of the API gateway output caching. The call comes to the API gateway. API gateway then routes the request to the actual microservice. There is also an element of API gateway is another layer. You see, one layer, two layer, and anytime you add a layer, there is a latency. But over a scale point of view, you gain advantage. So architecture is always trade-off, right? So if you see here, what are the three ways? You go to Lambda execution. Second, you can go to EC2 container-based approach. You can have your own third party or some other hosted version. It need not be a AWS service. As long as it has HTTP endpoint which it can hit API gateway, it will work. Yes. Sorry?
Endpoint is a kind of URLs, correct?
Yes.
And when you put that in the browser, it's going to execute for you.
So this endpoint is not available to these guys. The client does not know these endpoints. These are dynamic in nature. Many times, if you say EC2 container, it will spawn things at runtime, and it will create that dynamic port mechanism at runtime. That plumbing is here. The endpoint that is exposed to them is via the service discovery. Okay?
When you execute that one, you create a project like CodeStar, and ultimately you're running your Lambda and then give URL.
Yes.
Could you break that URL is, I think, first HTTPS : /
Yes.
and the first portion of that on your account number is correct? My account number, for instance, with Amazon. What are the other files?
It all depends on if you have internal DNS. You can have any kind of like name value mapping. It's FQDN, and that FQDN and port. Now, if you have a private DNS, you can have the mapping. I mean, and there is a dynamic that it spawns. Does it always have an account number as a prefix? I am not sure. But you could have a DNS-based prefix. You could have account-based prefix. At the end, it is a host name and a port. That's the key, host name and a port. ALBs or containers, they will spawn things at runtime, so there will be a dynamic URLs for them. But that plumbing is done, and gateway is aware of that, just like ELB is aware of the newer instances coming in, which is.
There's nothing just Amazon that ARN number?
Yes, yeah, and resource numbers also there. Okay, I need to, yes.
In the EC2 example, where you had I think, blue services and white services on the slide. So the load balancer in that case with no load services are available on each server and route properly. So So if I were to call a write service, for example, it would only route to the write EC2 instances?
Yeah, that's pretty much. The complexity is more when you have EC2 container on the same EC2 instance, different services, maybe multiple copies of it also available. So ALB does that magic of dynamic mapping, right? So, okay, so let's go through the 6 quick principles. You got to communicate via public HTTP 80.443. In olden days, we used to find out the dev who knows which database it is, and we could get around and get access to it. That is the anti-pattern. Once you get it, because it is hard for a database or any storage to know upstream and downstream dependencies. It's very hard. Unless you remove that, and that's when you figure out, okay, there are so many things dependent on it. So technically, do not give a backdoor entry to the storage or the shared database, any kind of storage layer. One another thing on the storage when you go in the cloud is there's the concept of this eventually consistent and strongly consistent, right? Now, just like when we started asynchronous programming and you're calling different asynchronous thread, at some point you want to make sure that these have finished before you proceed, right? That's the same idea here. Like, if it is the consistency, it's going to take time. You want to factor that in your design, that if I go to this particular instance, will I have the copied version or not? So you have to factor that in the strongly consistent, it's available there. Eventually consistent is where you have to factor that in. Microservices, this one is key. If you see versions, 1, 0, 0, major, minor, and patch, that's the semantic versioning. In this case, I changed minor. If you see, it's pretty much like I have added another overload for another function. So still can use it, but looks like I may move towards this. With the documentation, appropriate documentation, the clients can actually know, hey, this is going to be deprecated. You please make sure. And then eventually, when you move to the major version, you changed it. So you don't break the clients.
If I don't version it, it gives you $sign latest. What's that?
It probably is the last version that's there. API Gateway gives you last 2 versions at the same time. You can have multiple versions of the service being hosted, right? So your clients can actually communicate via, in this case, 1.1.0 and 2.0.0.
I think that's the default.
Yes. Okay, so write tools for write job. I mean, this is more on the storage layer. You will have different needs, so you should, like age old, I used to see in database, blobs, images, everything being stored. Not a place to store that, right? So that idea is there. The framework, this is another advantage, polyglot framework. In the old days, if you chose Java, every damn thing is Java. If you chose .NET or C#, everything is C#. With microservices, it's gone. Each service can choose their own platform. So a developer, if you say, hey, you are responsible for operations, he may say, no, I don't know. And you will give him that you have the right to choose which platform, which framework, which open source. Oh, he'll be super happy. So you give them something to be happy with. Operations, I don't know, I have a different take on that. Secure your service. Now this is important, right? We have the standard AWS-oriented defense in depth. You have the network isolation. This is key. Any API throttling is key. And before working in cloud, I really didn't have that much of respect for throttling. Now I really, really respect throttling a lot. I don't know, it still went down. Okay, so let him get it up. But throttling, I'll give you an example. Like I have seen. So,
Microservices are within your app and they're talking to each other.
okay, that's a very interesting question. You can have the end clients calling the API, you can have a service A call service B call service C, you could have, right? So now whether they go via public internet route and then come back, or whether they do just like a VPC endpoint where you don't want to go outside for the S3 access, there are ways in which you can get that working. So it's the DNS hoop that you can do the resolution so that it does not have to go through the public internet and then come back. Anything exposed outside that I can discover on, like service discovery protocols that are available, that's public, right? Anything that I don't want to expose, obviously you will have the factors in that it is only exposed within the VPC, and you will do the necessary security group for that. But the concept of multiple services talking to each other and not going outside will be a little bit of DNS trick that you'll have to do. Sorry? DNS trick that you'll have to do, like don't resolve the FQDN the outside. There is a routing that does internal based, yeah. Resolution, the route table based, there is a hoops that you can do that, okay? So throttling, I wanted to say one live example. There is an issue that happened. I'm not going to go into details of what the issue is. If you have designed throttling properly, it is such a good mechanism. Like if you see that there are n number of consumers for a particular service which is hammered thoroughly, if you don't have those knobs to throttle, it is very hard to troubleshoot those problems. If you have the knobs, throttle them. Bring down the number of requests that you can support. Throttling essentially means transactions per second that you're supporting for that service. So having throttling in the service will give you ability to troubleshoot them in those kind of complex scenarios. It's very important. Authorization and authentication, again, it goes back to who the caller is, right? That's one definitely. And again, OAuth, SAML, all that is supported by the custom authorizations of API gateway. You could have the standard access key-based mechanism. Most of the time I see federation in the enterprise world. Okay, so let's just do be good citizen. This is one good example. I need a service. Can I call you? Yeah. Tell me which one, and I'll let you know. Thank you. So this is one of the good citizens in terms of knowing who your caller is, maintaining a registry of the caller APIs. This helps you in whitelisting, DDoS kind of attacks, and being a good citizen, right? This is another one. Before we let you call our microservice, we need to understand your use case expectation. This was a big problem in the olden days. Like when you ask any customer when they were having performance issues, what's the expectation? Like what's the throughput expectation? How many calls you're expecting? Oh, we expect 1,000 users. Okay, is it concurrent? Is it one at a time? Is it 100 as concurrent? It's never flushed out. Is it for all the APIs? Which API? Never you'll get that answer. That is what is driving. Because if you have that information, you will better architect, design, and think through upfront. So getting those TPS numbers beforehand is always a good idea. Okay, be a good citizen. There are a lot of SLA-related questions. Now there's one thing on the client. Like we have been talking on the server side most of the time. The clients can do two key things. In cloud world, it is important to do retries and also exponential backoffs. So, you know, every now and then, because we are in the CI/CD DevOps world, there are things being released every 0.63 seconds. I'm sure you must have seen something appear in the Amazon.com and disappear, right? There can be sometimes that a service is for a millisecond not performing well. Your call at that time it came. I'll give you an example. IAM, you are creating an instance profile. Right that moment IAM service had an issue. What will happen? You'll get error. And if you don't have retry, everything goes away. Retry, having retries in your service calls is very, very important. Exponential backoffs is essentially like you wait for some time, you retry, still didn't work. You wait for some time, now multiply that. Because, I mean, 2 minutes, nothing happened, 4 minutes. So you pretty much have that some logic and not just hammering it again, retry. No, you saw it 3 times, it didn't work, wait for some time, and then you do it. That's from the client side. For the cloud world, it is very important to have. There is a quote from our CTO, Warner Vogels. Everything fails all the time. Self-healing and having those self-healing solutions implemented in your design is always critical in cloud world. This is one service which is going to be very, very useful for correlations. When I say correlations, from a UI, the call comes to web server, calls go to another service, call goes to a database, maybe call goes to another reporting, something like that. How do you know? How do you track? Like, hey, requester, I see your request, came to the web server, it went to this another service, it went to another service and database. X-ray is your answer. It gives you a correlation ID. You log correlation ID across, you'll be able to actually just put the correlation ID and see that request across the whole thread. That's the idea behind AWS X-ray, right? It's a tracing service which you can embed inside your application at each layer, UI, middle tier, wherever, and it will give you correlation. It's very, very super useful for correlation troubleshooting. Like, if somebody says slow, what is slow? One call is slow. Which user is slow? Okay, which request was that? It's easier. If you don't know, it's hard to actually troubleshoot that. Okay, automate everything. It's easier said than done, but with run instances API and with everything being able to do at runtime, sometimes I feel like DevOps culture, run instances API, microservices, they were all made to like somehow coincide and come together. This is the time. And everything can be automated, obviously, right? Doing your security design, doing your infrastructure provisioning, end-to-end automation is always a good idea. If somebody creates a VPC, I always ask them the question, can you recreate it? Like, I destroy and recreate it? You will find 10 steps which is manual there. So having that ability, like what if it goes down? I can recreate my whole environment within 5 minutes or 10 minutes or 2 hours. That confidence will give you such a peace of mind. It's easier said than done. That's also, I want to make that point. Okay, all the summaries that we have, rely on public, use the right tool for the job, secure your services, be a good citizen, more than just technology transformation. Microservices cannot happen if you don't change your DevOps culture. It's going to make it more worse. In that case, I would rather let you live in the monolithic world. If it is small, you don't have so many innovations, you probably live there. Automate everything, DevOps is the culture. Okay, that's the journey. We have this. Okay, today is Diwali, so I'm going to wish whoever celebrates Happy Diwali. Diwali has a quote, like, you are moving from darkness to light. You are moving from ignorance to knowledge. I will add moving from monolithic to microservices. Thank you.
Thank you, Amit. That was great. Are there any questions in the back?
It seems this architecture has a lot of overhead on each component. How's the performance regarding this?
So the question is, it seems like the architecture has a lot of overhead, so how's the performance? I actually might take a stab at answering that. When you're talking about just pure performance, you know, the contrast to this architecture would be a monolithic style architecture. And I think, you know, the speaker downstairs this morning from Betterment kind of pointed out that they started with a monolithic application and they were happy that that was their start. You have sort of an agility speed that you start to lose the bigger your monolith gets. The more people you add on, the more people, more developers you add onto a project, the more sort of constrained the knowledge becomes, the harder it is for you to make a change in that monolith. So you start rapid and you devolve. That's kind of the pattern that happens with a monolith. Microservices, on the other hand, that's the thing that they're trying to avoid, so that you can start rapid within a service and hopefully not devolve because the service itself is so simple. So as you make changes, you aren't necessarily worried about breaking something else that you hadn't thought of elsewhere in the platform. So as far as just pure performance goes, there are choices you can make about like what you're choosing to run your microservices with. You know, you can choose Go. It's very fast, very responsive. My last startup that I was at, we did a project where we converted from a Ruby on Rails app, Monolith, to microservices running in containers. And we were seeing, as we would take each function of that Rails app and break it off into a set of microservices, we chose Go as our language. And we were seeing calls that would take hundreds of milliseconds in Rails take, 2 milliseconds in Go. So by being able to make choices like that, one services team might like Go, another one might like Java. And being able to make those kinds of choices about one specific part of the application, you're able to pick the best tool for the job. So ultimately, you might pick up performance, even though it appears at first that there might be a cost to this style of architecture. Yes?
Even though you're allowed to pick the best tool for the job, it feels like when I look at tutorials and examples and I speak to people, you're kind of forced into DynamoDB. Just in terms of like the anecdotes that you get. I mean, I know DynamoDB isn't the only choice, obviously, is a thousand databases you could go with, but it seems like, I think Fauna's the name of it, that's the only other database that's like, that's schema, as opposed to schemaless, that is specifically targeted towards serverless stuff. So I was wondering if there's like best practices for using, more elaborate schematic databases.
I don't think I'm answering this question too, sorry. I don't think I've ever felt locked into DynamoDB. I think if you talk to people at Amazon, you're going to hear some fantastic stories about DynamoDB because we're very proud of how performant it is. But I think there are plenty of architectures out there that use other NoSQL solutions. There are a lot of shops that use Mongo. I've personally used Cassandra as a NoSQL data store that still has a schema. So yeah, I think there are plenty of examples out there, and nothing locks you into any one particular direction or another. I think if you read tutorials from Netflix, for example, you'll probably see a lot more around Cassandra.
Short terms, let me just mention, high club as far as language is concerned, the high club as far as data consistency is concerned. I mean, you can use any language for any given microservice, whatever works better, and any data store which works better.
Yeah, one of the points that Amit made earlier was that the data store should be with the microservice. So, as you're breaking down a monolith into its various components, it's not going to be one function of the monolith is one microservice. It's going to be one function of the monolith is one set of microservices. And those services together might talk to a single data store, and that itself could be Postgres for one set of services, and Mongo for another set of services, and Dynamo for a third set of services. There's no restrictions around that. It's just that's kind of how you group things together, is a set of services that are working together to provide one core bit of functionality of your application, and they tend to share a data store.
You mentioned that Lambda has a 5-minute maximum on the amount of time that a job can run. If you were
Today.
I'm sorry?
Today.
Today. Okay, so let's say tomorrow then. If you needed something, let's say like a load that would run once a week, that you just needed like a Lambda type functionality that would take more than 5 minutes, what would be a solution?
Can I answer?
There are options available. I'm a big containers fan, so ECS has a job scheduler that you could explore. AWS batch is another option. Those are the two service options.
Yeah, so batch level processing, I think, is probably what I would categorize that into. And we do have AWS Batch, which runs on ECS, by the way. ECS is our container orchestrator. And if you wanted to orchestrate it yourself through ECS, you could do that as well.
There's one additional thing I think I didn't have in the deck. API Gateway also supports integration with step functions. So there was a workflow before SQS. Now step function is like the high-level workflow. So you could simulate sub-level tasks via API Gateway with step functions also. Okay.
We have one more question here.
Okay, and we are since startup position, and this kind of model in software engineering, we like to make simple as possible, make it simple as stupid, the old saying. And so we have some idea, say in AI or machine learning. Do I have to employ all the techniques you have over here? simply I would like, okay, define my problem, what is my problem, and then some kind of design, and then implementation, test it, and do I have to employ the complicated technology, old technology of the Amazon?
Anytime a question starts with "do I have to," my answer is no. Do you want? So the question is basically, do I have to employ the techniques and services that we've talked about here to do things like AI on Amazon, or if I want to keep it simple, what are my options? Is that a good way to characterize?
I have my machine, old machine. Simply I would like to use AMI EC2 instance and forget about all the other security or complicated things.
So yes, you are free to architect and build as custom as you like. So EC2 is a great place for doing that kind of custom level stuff. I think a pattern that we see a lot is there are companies out there who are ahead of us as far as, you know, developing technology. I like to point at Netflix for this kind of thing, because Netflix, in a way, led us to a lot of the technologies that we now offer today. They had to build it before we had it available. And today, if you were going to build something like their architecture, we have lots of services that you'd be able to take advantage of. But if they don't work the way you really want them to work, then you have to figure out what's the best answer for your company. And is that go and customize it and run it all yourself, or is that adapt the way you expect it to work and give us feedback so that we can hopefully change the way our service operates as well? We're always listening for feedback, and we always encourage that from the customer. And if there's a feature that you feel like would get us from an 80% solution to a 90% solution or a 100% solution, we want to know about that kind of stuff, and we will take that and work on it. So we're always iterating on our services, trying to make them better. And if that's a good enough answer for you, if you can live with the 80% today, hoping that the 90 and 100 come in a while, then that's what I would recommend to help keep it simple. But if, you know, on the other hand, you need that extra today, then yeah, we have, you know, a custom path that you can do. You know, the sky's the limit on what you're able to do. All right, cool.